Well, good afternoon, everybody. So this last couple of weeks, we've been looking at coatings as the first line of defense against corrosion. The first session was on the specifications and the importance of making sure that the system that is being used is designed specifically for the application was underlined. Last week, we looked at the importance of surface preparation in order to make sure that whatever coating is applied has the ability to withstand the actual environments. So this week, we're going to look at the all-important aspects of quality control. And whilst this little 20-minute session is not going to turn you into a coating inspector, we hope that it will help you to identify some of the aspects of coating application which have to be considered when you're applying it. And one of those very, very important aspects of coating application, there is an old project management saying that, well, you can't make a baby in 1 month by impregnating 9 women. Just so you cannot circumvent the physical requirements that are necessary to ensure that your coating is correctly applied and cured and ready for service. So to take us through this session, I'm going to hand you over to Vanessa.
Thank you so much, Neil. And I extend my welcome as well to everyone as we look at this last session on the first line of defense being our coatings. The main aim of this mini series was really to take a closer look at coatings in general and try and remove some of the fear factor which might result in that. Now, as with all of our bite-sized corrosion presentations, we're really trying to aim to share some information that will assist you as the engineer in understanding some of the corrosion concepts and principles and practices to ensure that you're equipped to make sound decisions on site or to get specialist assistance in because you now have a good idea about what you don't know. Now, in our first week together, we did look at, as Neil said, at the coating specification. And we determined that the specification tells us what it needs to be. It needs to be specific. And it really is the guide for the corrosion protection of our structure. And last week, we zoomed in, pun intended, on the cleaning of our surface in how to make sure that our surface cleanliness is optimal to ensure that our coating or our corrosion protection system has the best chance of performing as designed. But the key question really is, how do you know? How do you, as the project engineer or the resident engineer, have confidence that you are getting the quality coating product that you're expecting and of course that you're paying for? You are now confident that your specification is sound and without contradictions, that it is specific to this project and that it's practical. And now you need the assurance that the implementation is in line with your expectations. Enter the coatings inspector. Now, coating inspection has a number of facets, and today we are going to primarily focus on the inspection of new works, more of a quality assurance role. In future episodes, we'll look at coating inspection and how it can be used in more of a forensic way to try and piece together the puzzle as to why or how a coating failure occurred. So let's get back to our new project. The reality is that the resident engineer is both too busy and, in all likelihood, not suitably trained to perform the coating inspection role necessary on our project. And whilst we are all aware that the coatings applicator is responsible to prepare and clean the surface, and of course to apply the coating in accordance with the specification, we also know that he is usually under time pressure and may have budgetary constraints. Of course, the coatings applicator is responsible for his own internal quality control, and he should have prepared a quality control plan which matches the requirements of the coating specification. But an independent third-party coating inspector will speak for the end client and for the resident engineer in their absence to ensure that the coating specification is indeed being met. Now, it is really important that the expectations for the coating inspector are clarified at a project kickoff meeting. In NACE parlance, it's a pre-job conference. This should be attended by the client and the engineer, the inspector, obviously, and the coating applicator at the very least. And the aim of this meeting is to try and clearly define the expectations of the client and the engineer, as well as the responsibility and authority that the inspector has. This meeting also provides the opportunity to clarify any questions or ambiguities, possible discrepancies that may exist between the coating specification and the standards to which it refers, as well as the technical data sheets of the coating that has been approved. Now, obviously, the inspector must be well versed in all of those documents and be well prepared. But another really important point of discussion is the communication tree. To whom should the inspector be addressing correspondence? Ideally, findings and concerns need to go up to the project manager and the RE, but it's very helpful to include the contractor in this, especially where challenges have been identified, to give the contractor a chance to start the process of finding solutions. We need to remember that it's a project team, and it comprises the engineer, the contractor, and the inspector. They're all working towards a common goal, to get the best possible structure for the client, obviously in the time. Challenges will be identified, and together they need to find effective solutions that the team can work together to achieve the goal. Using the approved QCP as a guide, the third-party inspector will be witnessing the work of the contractor and drawing attention to those areas or concerns where improvements are required. And it's important to remember that the specification is always the guide, and neither the client nor the inspector can insist on a performance level that is higher than that in the specification. So he will be looking for problems, identifying them, and trying to ensure that they are solved. The QCP will be highlighting those points where the inspector may want to hold the work to stop it until he's satisfied that the specification has been met. Now let's have a quick look at some of the tools in our inspector's toolkit, as it were, and how they can be used. Perhaps the most obvious and yet unstated tool is that of really looking and seeing what is going on, just using our eyes. The thorough inspector will be keeping an eye on general housekeeping. This is a not so subtle indication of the attitude and approach of the contractor to the project. A well-organized and tidy project site will indicate some pride in the work and an expectation of attention to detail on the coating job. The first important factor daily, of course, is keeping in mind the weather. Keeping an eye on the climate conditions at the coating site, which is critical to make sure that the temperature and the relative humidity are appropriate for the blasting and coating processes. And it's not just the ambient temperature, which is obviously recorded using nowadays modern digital thermometers and psychrometers, but also the surface temperature is really critical to make sure that we have what it takes to get our coating to adhere appropriately to our structure. And your inspector is going to not want to just go on a rule of thumb of degrees that everybody says work, but actually work with the real specification, not a bottom drawer specification, to make sure that it is appropriate. One may need to modify the cleaning and coating environment in order to meet the requirements of the specification. And of course, while the inspector is keeping an eye on the conditions, it is still the contractor's responsibility to ensure that the work area is suitable, perhaps putting up shade. The next aspect in the sequence of the coating process that the inspector is going to look for is the surface preparation. What are we starting with? And then where do we want to end up? We know that the surface preparation is an area where many discussions and disagreements may occur. And of course, that kickoff meeting is going to clearly remind everyone of the expectations. Cleaning oil and grease is fairly straightforward and usually proceeds with little drama, and the inspector's job may be quite easy at this point. Cleaning up weld spatter and mechanically smoothing fabrication defects may also go fairly smoothly. But it's in the removal of salts where challenges can commence. And again, we looked at this last week. There are certain chemicals one can add to the wash water as inhibitors or salt removers. It is a warning that if the contractor intends to use this, you as the engineer and the inspector must ensure that you receive written confirmation from the coating manufacturer that these chemicals can be used in conjunction with their coatings and that their use will not nullify any guarantees. Salt tests are usually performed by the contractor and merely witnessed by the inspector. And obviously in a critical application, this might be a hold point. Blasting, obviously the standards that are being called for must be agreed. And as I mentioned last week, there's a general misconception that a certain amount of mill scale is permitted in SA 2.5. I repeat, this is incorrect. Absolutely no mill scale is permitted in either SA 3 or SA 2.5 levels of cleanliness. And it will be something that a good inspector is keeping an eye on. If it's possible, a good way to maintain the project standard is actually to prepare a set of reference panels for the project at the outset. Once all the parties are in agreement with the level of cleanliness, these panels can be sealed in plastic and then be retained through the project for ease of reference. A very small step, which can ease future aggression later in the project when time becomes of the essence. It's also really important to ensure that the blasted surface doesn't get exposed to the environment, particularly if there are humid conditions. And of course, there should be no coating permitted at humidities of more than 85%, but that might even be lower dependent on the specific coating that has been specified. The concern, of course, with humidity is not only flash rusting, but also it can form that layer of condensation on the surface, and it can prevent solvent evaporation from our coating, even if the solvent in your coating is water. So we can imagine how our rate of coating progress is going to be determined by the weather, and that often puts time pressure on the project. Ideally, blasting and coating should be conducted in a controlled environment, because in a shop it's easier to control the humidity and the temperature, but that isn't always possible for big structures. So perhaps temporary shelters may aid this to minimize the impact of the environment. The blast media is often not prescribed for blasting, but the choice of grit size will be determined by the desired profile. And the specification needs to be very clear on the average and the minimum profile that is permitted. Now, the frequency of testing and who does the testing will be guided again by the specification. And the third-party inspector may well verify the profile either using replica tape, such as Testex, as demonstrated here, or with a profile gauge. And it goes without saying that the inspector will examine the hard-to-reach areas to check that they meet the specification. Remember, corrosion starts in the place most difficult to access. So it's worth getting this right at the start. A step in the process which sometimes gets neglected, but which the inspector is also keeping his eye on, is the amount of dust and debris on a surface. And it's really important to vacuum or remove all of those dust particles to ensure that they don't stop adhesion. This can be tested using clear tape so that you can visualize how much or how little dust remains on the surface. In addition to this, the inspector is keeping an eye on a number of other aspects. For example, the number of coats and their thickness. Again, the specification should be defining what the minimum and maximum coating thicknesses are and the accepted average. And this will apply to the individual coats as well as to the overall dry film thickness, or DFT as it is called. Remember that a coating that is applied too thinly will not provide adequate protection for the structure from the environment and can manifest as pinholes. And too much coating isn't also necessarily a good thing. If you apply your coating too thickly, you may get sagging, and you may get lack of curing, you may get solvent entrapment, and of course you may get poor adhesion. And this may happen if your coat is applied too thickly. Effectively, your coating is adhering more strongly to itself than it is to the substrate, and so it cannot hold up against gravity. And as they always say, gravity always wins. And when that happens, you've got loss of adhesion and a coating failure, or in some cases, complete delamination. It's important to remember too that the coatings draw back from the edges, and so inspectors will spend some time ensuring that appropriate stripe coating is applied on edges and other critical locations before the final coat is applied. Now, your coating thicknesses are areas where disagreements can abound, and if we're going to consider the minimum and maximum and average values, again, we need to know what are the criteria against which we're going to be measuring. There are a number of different coating thickness protocols. Each specifier has his or her own preference, and there needs to be very clear designation of what is being chosen and agreement in it at the kickoff meeting to ensure that everybody knows what the protocol is that's going to be used and how it will be applied. Using modern electronic thickness gauges is very helpful, as many of these devices store the data electronically, and that can be printed out later as a record rather than a photograph. But checking the coating is not the only aspect of the coating application that your inspector is going to be keeping an eye on. He's also going to ensure that the various batches of the coating are kept and used together, and that they are mixed appropriately, and that the ratios are appropriate too. Getting it wrong can be the cause of your coating never curing, and that will be a disaster. And in some instances, your coating may actually set up before it's sprayed, and even if it can be sprayed, it will never adhere to the surface, so it's failed before it's even got out of the starting blocks. And we want to avoid that at all costs. It's particularly difficult with those coatings that have unusual ratios. Some of the modern coatings where it's a 1:11 ratio, or in the older coatings that are a 1:2 or 1:1 ratio, the mixing of ratios is a little less difficult to get right every time. In the grand scheme of our project, the coating application is really a small process, but the results of it going wrong can have catastrophic and long-reaching effects on the entire project and on its intended life. By using a dedicated coating inspector, of course, the resident engineer can transfer some of the responsibility onto a trained person, and then he's free to focus on other management aspects on the project. Making sure that our coating is applied as carefully as possible, the best possible conformance to the specification, really does give the project its best head start in life. And hopefully this mini-series has given you just a couple of pointers to help you also achieve this in your project.
Thank you, Vanessa. You mentioned earlier in your presentation that the inspector needs to be qualified. When I started in the industry a few decades ago, my then boss had the opinion that for an inspector to be effective, he had to be able to go onto a job site and whatever the contractor was doing, be it blasting or spraying or metal spraying or whatever, the inspector needed to be able to take the piece of equipment, whatever it was, and do the job as well, if not better. That's quite a task. Is it really necessary? What's your opinion?
That's a difficult question to ask. I guess my perspective is that it's a good idea that the inspector does know a little bit about every facet of the job. He or she should be able to at least have attempted some of the or all of the aspects to have a real feel for how the problems can occur. Whilst I think there's merit in gaining good experience on site, the majority of coating inspectors today don't come up through the role of being the applicator first and then moving on to becoming the inspector. And so I think perhaps today it's acceptable, maybe not the best, but acceptable that an inspector has had some experience, but not necessarily the best in the field.
Obviously, the inspector needs to be experienced and qualified in inspection, and he needs to know how to use his tools and how to read specifications and so on. Certainly, when you're troubleshooting, it helps if you understand something of the application processes. We have another question. On many commercial projects, which are lower risk, there is no insistence from the professional team, either the structural engineers or the architects, on quality control. Contractors are then very often left to take shortcuts without any checks and balances. Do you have any advice for these situations?
I guess the cocky answer is that one needs to encourage the project financier in the value of having some kind of third-party inspection. It doesn't have to be full-time, but there's definitely merit in checking someone's work. I think that's applicable in all aspects of life. I think it was quite noticeable during hard lockdown when we had children at home instead of at school having to do work, and parents becoming aware of what work was and wasn't being done, because suddenly mom or dad could peep in and see. And I think it's exactly the same if a project can have some kind of independent call out. Sometimes it can come from the manufacturer. It's very often in their interests to double check, quote, inspect the work being done, because it's their product that's on the line. So if I manufacture a particular coating, the last thing I want is for it to fail and be labeled as my coating, when in fact I'm fairly confident that it was the contractor taking shortcuts, and they do take shortcuts. We've seen numerous examples where they've used the wrong specified, particularly primer. The primer's hidden, so they'll go to the hardware store and buy the cheapest possible paint that they can throw in at the bottom. Nobody will see it. It's sort of the right color, and then there's a failure. If on a commercial project there isn't an insistence for professional quality control, I think it should be pushed back by the project, by the engineer, to say, really, this is worth doing, if not as a full-time basis, certainly as a pop in and have a look. I don't know if you've got any other comments that you'd like to add, Neil.
I think one of the biggest challenges that we have is that all too often people doing quality control get called in when the job's finished. Here's a coated structure, please inspect it and sign it off. Certainly in my experience in a situation like that, I'm afraid the short answer is no. I didn't see the surface preparation, I didn't see the primer, I didn't see the intercoats, I didn't see the final application. I'm not going to sign for it. I'm not putting my name on the line. And unfortunately, many times in coating application, the final product looks great for the first 3 months or the first 6 months, or it might even last till the defects notification period, and then falls off. And then you've got a cost which is maybe up to 10 times greater than it would have cost to do it properly the first time round. So it really is a challenge. And this is really one of the primary reasons why we've embarked on this Bite-Sized Corrosion series, is to try and raise awareness in the industry amongst everybody, amongst the engineers, amongst the financiers, amongst the project managers, in order to ensure that things get done properly the first time.
I think the Afrikaans saying goedkoop is duurkoop is so applicable. Very often the financiers are the ones who drive the selection of the coating applicator, restrict the quality assurance, and don't realize, as you rightly say, that next year or well before it should have failed, there's a failure that has a very costly rework implication. It's never cheaper by taking shortcuts.
So folks, that brings us to the end of this little mini series that we've done on coatings. We hope that you have enjoyed it. We're going to be back in April with another short series on materials and the selection of materials for corrosion control. We look forward to seeing you again in April. Thanks and goodbye for now.